In the early 1940s, as Europe faced World War II, the skies became the new decisive battlefield. The German Luftwaffe dominated the air with technical and tactical superiority. Its fighter formations seemed invincible, and Allied bombers that dared to penetrate Reich airspace suffered significant losses. It was a time of desperation, when each bombing mission meant saying goodbye to entire crews who might never return home. Allied generals knew they needed something revolutionary, something that could turn the tide in the air. But what they didn't know was that the solution would come from a completely unexpected source, from an unlikely team working against all odds, and from engineering decisions that defied the conventional wisdom of the time. This is the story of the P-51 Mustang, the fighter that should never have existed, initially rejected by the Americans themselves, but which ended up becoming one of the most effective combat aircraft ever created to dominate the skies. It is a story of improvised genius, of international collaboration forced by circumstances, and of how small technical decisions can change the course of world history. But above all, it is the story of visionary men who saw possibilities where others saw only limitations. Before we continue with this fascinating story, if you're not already subscribed to the channel, click the subscribe button now and leave a comment telling us what time you're watching this video. This greatly helps us continue bringing you quality content about military history and aviation. We need to go back to 1938 to truly understand how it all began. At that time, military aviation was still relatively young. Only 2 decades had passed since the first fighter planes clashed in the skies of World War I. The American aircraft industry was fragmented, composed of dozens of small companies competing for limited government contracts. Among these companies was North American Aviation, a relatively obscure company based in Inglewood, California, that had specialized primarily in training aircraft. They were good at what they did, but no one considered them pioneers in fighter design. The president of North American Aviation was a man named James Howard Kindleberger, known as Dutch to his friends. Dutch was a Texan, an engineer by training and a visionary by nature. He had previously worked for Douglas Aircraft and was intimately familiar with both the possibilities and limitations of the aeronautical technology of the time. Alongside him was Edgar Schmud, a German-born engineer who had emigrated to the United States in the 1920s. Schmud was a perfectionist obsessed with aerodynamics, a man who dreamed of aircraft that could cut through the air like knives, minimizing every ounce of parasitic drag. These two men would form the central duo behind what would become the Mustang. In April of 1940, while the German Blitzkrieg swept across Western Europe, the British Purchasing Commission arrived in the United States with a desperate mission. Britain was alone against Nazi Germany, France was on the verge of collapse, and the Royal Air Force urgently needed more fighter planes to defend the British Isles. The British were already buying the Curtiss-Wright P-40 Warhawk, but production couldn't keep up with demand. They needed more factories, more planes, more of everything. The British mission approached North American Aviation with a seemingly simple proposal: to build P-40s under license to accelerate production. It was a good, predictable, risk-free deal. Any other company would have accepted immediately. But Dutch Kindleberger saw something different in this opportunity. He knew that the P-40, although a decent fighter, was already becoming obsolete. Its design was based on concepts from the 1930s, and the Germans were flying more advanced machines. Kindleberger then made a bold proposal that left the British stunned. Instead of building old P-40s, what if North American designed and built a completely new fighter from scratch, using the latest lessons from European air warfare? The British thought he was crazy. Designing a new fighter jet from scratch normally took years, sometimes a whole decade from initial concept to mass production. But Kindleberger assured them his team could do it in months, not years. He had a lean, hungry team, free from the bureaucratic vices of large corporations, and he had in Edgar Schmud a genius of aeronautical engineering. More importantly, he had access to something precious: data. Here is one of the most fascinating and least known aspects of the Mustang's history. The British had been fighting the Luftwaffe for almost a year, and they had learned valuable lessons about what worked and what didn't in real aerial combat. They had measured the performance of captured German aircraft, interrogated pilots, and analyzed every aspect of modern aerial combat. And now, desperate for aircraft, they were willing to share all this data with North American Aviation. It was an unprecedented transfer of knowledge, gained through the combat experience of British pilots in the skies over England. Edgar Schmud immersed himself in this data like a dedicated academic in a valuable library. He studied every combat report, every performance analysis, every piece of intelligence on German fighters. What he discovered fascinated and deeply worried him. The Germans had advanced far more than most Americans realized. The Messerschmitt 109 was not only fast, it was extremely effective at altitudes where other fighters lost power. But Schmud also noted weaknesses, opportunities, areas where a superior design could gain an advantage. Schmud's team had 120 days to transform paper and dreams into metal and reality. It was an impossible deadline, but it was what the British were willing to wait before simply ordering more P-40s. The clock started ticking, and the North American team began what can only be described as an engineering sprint. They worked 16, 18 hours a day, 7 days a week. There was no time for multiple prototypes, for extensive testing of each component. Everything had to work correctly the first time. Schmud made design decisions that were radical for the time. First, he insisted on an extremely aerodynamic fuselage, using what became known as a laminar flow. In simple terms, this means that the wing was designed to maintain a smooth, laminar airflow over its surface for as long as possible, delaying the transition to the turbulent flow that creates drag. It was a theory that existed in aerodynamics textbooks, but few had attempted to implement it in a real combat aircraft. Most engineers considered it impractical because it required extremely precise manufacturing tolerances. But Schmud persisted, and his obstinacy would pay enormous dividends. Second, he placed the engine radiator not at the front of the aircraft, where it traditionally was located, but under the fuselage behind the pilot. This seemed counterintuitive. Everyone knew that radiators created drag, so why place it in such a prominent position? But Schmud had calculated something brilliant. If the radiator duct was designed correctly, the heated air passing through the radiator would expand and accelerate as it exited, creating a small amount of additional thrust. This effect, known as the Meredith effect, could in theory completely offset the radiator drag, or even create positive net thrust. Again, it was a theory that few had tried in practice. Third, Schmud designed an extremely narrow fuselage, fitted around the engine. Every inch of frontal area meant more drag, so he eliminated all wasted space. The cockpit was positioned well back, giving the pilot excellent visibility. The tail was clean and efficient. Every panel, every rivet, every surface was optimized for minimal drag. In just 119 days, 1 day ahead of schedule, the first prototype was ready. It was a beautiful aircraft, with fluid and elegant lines that suggested speed even when stationary. The British were impressed. They christened it Mustang, following their tradition of naming American fighter planes after horses or Native American warriors. The name was perfect, evoking speed, power, and indomitable spirit. The first flight took place in October 1940, with test pilot Vance Breeze at the controls. From the very first moment, it was clear that something special had been created. The aircraft was exceptionally responsive, stable at all speeds, and surprisingly fast. At low altitudes, it surpassed everything the British had. There were problems, of course, bugs that needed fixing, adjustments to be made, but the basic structure was solid. But then came the disappointment. When the aircraft was tested at higher altitudes, its performance dropped dramatically. The Allison engine that powered it, although excellent at sea level, simply didn't have enough power when the air became thinner above 15,000 feet. And air combat over Europe was mainly taking place between 20 and 30,000 feet. Bombers flew high to avoid anti-aircraft fire, and fighters had to fly even higher to protect them. The British were divided. The aircraft was magnificent in many respects, but with that engine, it was unsuitable for the role of escorting bombers over Europe. They accepted it nonetheless, but assigned it to ground attack and low-altitude reconnaissance roles, missions where its exceptional low-altitude speed was advantageous. The Mustang seemed destined to be a footnote in history, a good fighter that came close but failed to achieve greatness. The United States Army Air Forces paid little attention to the Mustang. They were focused on their own fighter programs, particularly the P-38 Lightning and the P-47 Thunderbolt. Both were powerful machines capable of fighting at high altitudes, but both had their own limitations. The P-38 was expensive and complicated to maintain, with its twin engines. The P-47 was a heavy, extremely robust monster capable of absorbing immense damage, but it guzzled fuel and had limited range. Range was the critical problem. In 1943, when American bombers began their daytime strategic bombing campaigns over Germany, they faced severe losses. Formations of B-17 flying fortresses flew deep into German airspace, but their escort fighters had to turn back when fuel ran out, usually before reaching their targets. Once the Allied fighters returned, the bombers were left alone, and German fighters intercepted them with devastating effectiveness. Losses were unsustainable, sometimes exceeding 10% per mission. At that rate, bomber crews had no statistical chance of surviving the full mission cycle. It was in this desperate context that a small group of visionaries began to look at the Mustang again. Among them was Ronald Harker, a British test pilot for Rolls-Royce. Harker flew a Mustang in April 1942 and was absolutely amazed by the aircraft's handling and aerodynamics. But he also immediately noticed the engine problem. And then he had a brilliant idea. What if they replaced the Allison engine with the Rolls-Royce Merlin? The Merlin was a masterpiece of British engineering, the engine that powered both the Spitfire and the Hurricane, the fighter planes that saved Britain during the Battle of Britain. What made the Merlin special was its two-stage supercharger, which compressed the rarefied air at high altitudes, allowing the engine to maintain power where others failed. It was exactly what the Mustang needed. Harker's suggestion found receptive ears at Rolls-Royce, and soon 5 Mustangs were modified to receive Merlin engines. The results were nothing short of spectacular. Suddenly, the Mustang wasn't just good at high altitudes, it was exceptional. The combination of Schmud's super-efficient aerodynamics with the power of the Merlin created something magical. The Mustang with the Merlin engine was faster than anything in the skies, capable of reaching speeds exceeding 440 miles per hour. It could climb quickly, dive without structural problems, and maneuver with agility that defied its speed. But the most important feature was its range. Thanks to its exceptional aerodynamic efficiency, the Mustang consumed less fuel than any other high-performance fighter. When equipped with disposable external fuel tanks, it could fly over 1,500 miles round-trip. This meant it could escort bombers to Berlin and back, something no other Allied fighter could do. It took time for the military bureaucracy to process this information. There was institutional resistance, loyalties to existing programs, skepticism about modifying an American design with a British engine. But finally, in the summer of 1943, the decision was made. North American Aviation would receive massive contracts to produce the P-51B and P-51C, versions of the Mustang equipped with the Merlin engine built under license by Packard in the United States. The Mustang was finally going to war in the role Edgar Schmud had always dreamed of. The first group of P-51s arrived in Europe in November 1943. American pilots were initially skeptical. Many were veterans who had flown P-47s or P-38s and were attached to their machines. They looked at the Mustang with its narrow fuselage and wondered if it would be robust enough. But from the first combat flight, the doubts dissipated. The Mustang was a revelation. One of the first pilots to master the Mustang was Lieutenant Colonel Don Blakesley, commander of the legendary 4th Fighter Group. Blakesley was a veteran who had fought with the RAF even before the United States entered the war, and he immediately understood the Mustang's potential. He pressed his superiors to convert his entire group to the new fighter, and when this was approved in February 1944, the 4th Fighter Group became the first American unit fully equipped with Mustangs. The impact was immediate and dramatic. For the first time, American bombers had escorts that could stay with them for the entire mission. Mustang pilots developed new tactics, abandoning the tight defensive formation that had been necessary when range was limited, in favor of a more aggressive approach. They hunted German fighters, actively sought them out, forced them into combat. And when the combat began, the Mustang revealed its true colors. In aerial combat, the Mustang had advantages over almost all German fighters. It was faster than the Messerschmitt 109 at all altitudes, and significantly faster at high altitude. It had better acceleration and better dive speed. It could turn tighter than the Focke-Wulf 190 and had better cockpit visibility than both. German pilots found that their old tactics no longer worked. They couldn't simply dive through bomber formations and escape, because the Mustangs would catch up with them. They couldn't outmaneuver the Mustangs in circling combat. Their only advantages were experience and, increasingly rarely, numbers. The names of the Mustang aces began to become legendary. Don Gentile, known as the Ace of Aces, who shot down 30 enemy aircraft. Chuck Yeager, who would later break the sound barrier, began his career by shooting down a Messerschmitt 262, the revolutionary German jet fighter, with his Mustang. George Preddy, who would become the Mustang's leading ace with 26 confirmed kills. Bud Anderson, who survived 116 combat missions and became one of the most respected pilots of the war. But the Mustang's contribution went beyond the number of kills. The psychological effect on the Luftwaffe was devastating. For the first time since the beginning of the war, German pilots were fighting defensively, on their own territory, against an enemy that had superiority both in quality and, increasingly, in numbers. The German veterans, the experts who had dominated the skies of Europe in the early years of the war, were being gradually outpaced. And the young, inexperienced pilots who replaced them had no chance against the well-trained Americans in their superior machines. Hermann Göring, the Luftwaffe commander, supposedly said he knew the war was lost when he saw Mustangs over Berlin. It was a bitter admission of reality. Germany had gambled everything on the belief that Reich airspace was inviolable, that Allied bombers could never penetrate deeply with fighter escort. The Mustang shattered that illusion completely. In 1944, North American Aviation was producing Mustangs at an astonishing rate. The assembly lines in Inglewood were working 24 hours a day. Continuous improvements were incorporated. The P-51D, introduced in mid-1944, added an acrylic bubble in the cockpit that gave the pilot 360-degree visibility, eliminating the blind spots that had plagued previous versions. It also carried 6.50 caliber machine guns instead of 4, increasing its firepower. The Mustang's versatility also became apparent. In addition to its primary role as an escort fighter, it excelled in air superiority missions, sweeping German airfields, attacking trains and supply convoys, and providing close air support for ground troops after D-Day. There were very few missions the Mustang could not perform effectively. On the Pacific Front, although arriving later and in smaller numbers, the Mustang also proved its worth. It escorted B-29 superfortresses on long-range missions against Japan, flying from bases on Iwo Jima and other captured islands. Japanese pilots, facing fuel shortages, inadequate training, and increasingly obsolete aircraft, found the Mustang to be just as effective as their German counterparts had discovered. When the war ended in 1945, the P-51 Mustang had set a remarkable record. Mustang pilots had claimed some 5,000 enemy aircraft shot down in the European theater alone, more than any other Allied fighter. But perhaps more important than the kill numbers was what the Mustang enabled. The strategic bombing campaign that destroyed Germany's industrial capacity to continue the war. Without the Mustang, this campaign would have been impossible, or would have cost so many lives that it might have been abandoned. The Mustang's legacy extended far beyond World War II. It served with distinction in the Korean War, where jets were beginning to dominate, but where its reliability and ability to operate from makeshift airfields still made it valuable. Many countries around the world operated Mustangs in their air forces. And in civil aviation, modified Mustangs became favorites in air races, where their speed and maneuverability still impress decades later. Today, restored Mustangs are prized treasures, flown in air shows where crowds marvel at their grace and power. The distinctive sound of the Merlin engine, a deep roar that rises to a high-pitched howl at full power, still sends shivers down the spine of anyone who hears it. For many aviation enthusiasts, the Mustang represents the pinnacle of piston-engined fighter design, the point where art met science and created something truly perfect. But what makes the Mustang's story truly remarkable is not just that it was an exceptional machine, but how it came to exist. Consider the improbable circumstances. A second-rate company is given a chance to build a completely new fighter jet, despite never having designed one before. They have only 120 days to do it. They have access to invaluable British combat intelligence. They have a chief engineer who is, frankly, a genius and who is willing to risk everything on unproven ideas. They create a magnificent aircraft that is, however, inadequate for its intended purpose because of the wrong engine. Then, almost by accident, someone suggests swapping the engine, and suddenly all the pieces fit together perfectly. At every stage of this journey, things could have gone wrong. The British could have insisted on the P-40s. North American could have played it safe. Schmud could have followed conventional designs. No one might have thought to experiment with the Merlin engine. Military bureaucracy could have blocked the project. But instead, all the right decisions were made, all the right people were in the right places, and the result was an aircraft that changed the course of history. The story of the Mustang is also a testament to the power of international collaboration in times of crisis. It was an American aircraft designed by a German-born engineer, powered by a British engine, created in response to British needs, and produced urgently because everyone understood that the freedom of the world was at stake. It was industrial democracy at its best, capitalism and free enterprise harnessed to defeat tyranny. Edgar Schmud, the silent genius behind the design, never received the fame he deserved during his lifetime. He was modest, preferring to let his work speak for itself. After the war, he continued designing aircraft, including the F-86 Sabre, which would dominate the skies in the Korean War. But the Mustang remained his greatest achievement, the aircraft that proved that elegance and effectiveness could coexist, that efficiency was not only desirable but essential. James Kindleberger, who had the vision and audacity to propose building a new fighter jet from scratch in 120 days, proved that leadership matters. His willingness to risk his company's reputation on an impossible gamble paid dividends not only for North American aviation, which became one of America's leading aerospace corporations, but for the free world. And the drivers, young men in their 20s who climbed into their Mustangs knowing that each mission could be their last, who fought against a desperate and skilled enemy. They are the true heroes of this story. The Mustang was just a tool, but in the hands of brave and skilled men, it became a weapon that saved countless lives by shortening the war. There are profound lessons in this story for our times. It teaches us that innovation often comes from unexpected places, that smaller, more agile companies can surpass established giants when they have the right vision. It shows us that impossible deadlines sometimes produce the best results, that pressure can turn coal into diamonds. It demonstrates that data and intelligence, freely shared among allies, can multiply everyone's effectiveness. The story of the Mustang also reminds us that technology alone does not win wars. The Mustang was exceptional, but without the courage of the men who flew it, without the strategy that employed it correctly, without the political will to continue the fight when all seemed lost, it would have been just another aircraft. It is the combination of superior technology, intelligent tactics, human bravery, and a just cause that wins conflicts. Looking back through the decades, it's remarkable to think how much depended on a single aircraft. Had the Mustang not been developed or had it failed, the strategic bombing campaign against Germany might have been abandoned. Without that campaign, German industrial capacity might have continued producing weapons, the war might have dragged on for years, millions more lives might have been lost. The atrocities committed by the Nazi regime might have continued longer, victimizing even more innocent people. The invasion of Europe might have been delayed or might have failed. Of course, history is not determined by single machines. There were many factors that led to the Allied victory in World War II. But among these factors, the P-51 Mustang occupies a special place as the weapon that broke the Luftwaffe's back, that made the skies over Europe safe for Allied bombers, that allowed Nazi Germany to be defeated from the air before it was defeated on the ground. When we contemplate the Mustang today, whether in a museum or gracefully flying in an air show, we must remember that we are looking at more than just a beautiful and fast aircraft. We are looking at an instrument of liberation, a tool that helped restore freedom to millions of people who lived under oppression. We are looking at the product of human ingenuity applied to a moral purpose, proof that when free men work together for a just cause, they can accomplish extraordinary things. The P-51 Mustang teaches us that greatness often arises from necessity, that the greatest advances frequently occur when there is no time for doubt or fear, only for decisive action. It shows us that collaboration overcomes isolation, that ideas from many minds can create something greater than any individual could imagine alone. And it reminds us that, in critical moments of history, small groups of dedicated people can truly change the world. So, the next time you see a Mustang, whether on movie screens, in historical photographs, or, if you're very lucky, roaring through the skies at an air show, pause for a moment and appreciate not just its aesthetic beauty, but the miracle of its existence. Think of the engineers who defied conventional wisdom, the workers who built it on assembly lines that never stopped, the pilots who took it into battle knowing they might not return, and the leaders who had the vision to see its potential when others doubted it. The P-51 Mustang remains, decades after its last combat mission, a testament to what humanity can achieve when necessity, opportunity, and genius converge. It is a reminder that in times of darkness, when the forces of tyranny seem invincible, men and women of goodwill can create tools of liberation. And it remains an enduring symbol that freedom is worth fighting for, that innovation can change the course of history, and that even in humanity's darkest moments, the light of genius and courage can shine and show the way to victory. This remarkable aircraft, born of desperation and urgency, refined by ingenuity and collaboration, and battle-tested over the skies of Europe and the Pacific, secured its place not only in military history, but in the history of civilization. The Mustang helped preserve the free world in its moment of greatest peril, and for that reason, it deserves to be remembered and honored not only as a machine but as an instrument of divine providence that, through human intelligence and courage, worked to restore justice and freedom to a world plunged into darkness. May we always remember the lessons of the Mustang, that innovation is born of necessity, that collaboration multiplies strength, that courage makes the impossible possible, and that when free men unite in defense of liberty, they can overcome any adversary, no matter how powerful they may seem. And may we thank the Lord God for giving humanity the intelligence to create such instruments of liberation, and the courage to use them in defense of what is right and just.